This is question 52 in chapter 9 of our physics textbook. And so in question 52, it describes that to escape a predator, a squid that's floating around the surface of the water will eject water to basically escape the predator, propelling it into the air before it splashes down. And there's two parts to this question. The first part of the question is if we have like a 36 kilogram squid that is ejecting water at a velocity that is achieving a takeoff speed of 3.5 meters per second, and it's ejecting a mass of 3.0 kilograms of water. The question in part A is, what speed is the water that's being ejected from the squid? So to solve this, using the conservation of momentum, we can derive this equation here, m1 v1 equals m2 v2, because we know that the momentum on one side has to equal the momentum on the other side. And so basically, once we have this equation, we can solve for our v2 by setting it to v2. So the equation that we've derived now is v2 equals m1 times v1 over m2. And then at this point, all we need to do is enter in the information that we have been provided. So our v2 equals 36 kilograms times by 3.5 meters per second, all over 3.0 kilograms. And once we run that through run it through like a calculator, we end up getting 42 meters per second, which is the speed of the water that's getting ejected from the squid. So once we have this velocity, then we can attempt the second part of this question, which is part B. Part B asks if the squid is getting ejected out of the water, what is the maximum horizontal range it can come to before it basically splashes back into the water. And so to solve this equation, the final equation that we need to use is basically h max equals our initial velocity times by the change in time. But because we're not provided the change in time in the problem itself, we need to solve for the change in time. So to do that, we have to use this equation here, which is a kinematic equation. Vf equals v initial plus acceleration times the change in time, which in this equation, our acceleration will be the acceleration of gravity. And so what we need to do is set it to solve for our change in time, which, because our final velocity is going to be 0, basically what we get is change in time equals our initial velocity over the acceleration of gravity. And so once we enter these into our equation, we get our initial velocity, which was the 3.5 meters per second, which is the velocity of the takeoff of the squid, and the acceleration of gravity, which is 9.8 meters per second squared, and we get 0.357 seconds, which is the change in time. So once we have this, we can now enter it into our final equation. So we get h max equals our initial velocity, which is the 3.5 meters per second of takeoff, and the change in time, which is 0.357, which will give us an answer of our x max equals 1.25 meters. So the answer to part B is the max horizontal range that squid can achieve, which would be at before it splashes back down into the water, would be 1.25 meters. And that's how you'd solve this question.